This would be the middle bearing, would be the intermediate bearing on continuous application. These would still be the end bearing. So the middle bearing, these would be some details that are standard. If you have a load bearing wall above, so if you've got, let's say your roof is coming here and there's a bearing wall and it's trying to drop a bunch of load down through this here. Now your I-joist is going continuously. So in order to help transfer that load through, you got to have a row of blocking panels on top of that wall between the joists to help transfer that load, because you have some load that might fall somewhere between the joists. Okay? So that's one typical detail. Now an alternate to that would be the next one, where let's say you had some mechanical or something going through there and you don't have space, or you can't accommodate having a blocking panel there. Well, then squash blocks on either side of the joist, which are just 16 higher, would help that load from above to go around the joist, so that the joist doesn't take the brunt of all that load from above. Okay, so that's an acceptable alternative detail to a load bearing, to load coming down on an intermediate bearing. Okay, and when you don't have any load coming from above, so let's just say it's a continuous span, and you have roof trusses and they all get distributed to the outside walls. There's no load coming down the middle. Then you don't need anything on the wall. The joist just running continuously away. Okay. Whereas if you're doing this with 2x10s, for example, well, you have to have one joist from here to here, you'd have to have another joist from here to here, and they'd have to overlap, and you'd have to have blocking in between. Okay? So a lot more tedious to frame, it's a lot longer, whereas you come along, you have two 15-foot spans. With 2x10s, you'd have to have two 16-foot joists, and you'd have to overlap them and have a section material. With an I-joist coming in with a 30-footer, bang, you're done. Okay? So some other advantages to using an I-joist versus a 2x2. We looked at that deck attachment a while ago. So we have in our publications, we have a table there that would say if you have half-inch bolts spaced at every 2 feet, how much load could it carry? So we actually have load tables for how much you can actually bolt to the side of a ringboard, okay? Which isn't the case if you're using some competitive OSB ring boards, because it's timber strand, it's got some very specific strengths and properties to it, whereas other ring boards don't have that kind of support. Okay, web stiffeners is something we would not see very well, typically with a 2x floor. Okay, those are web stiffeners or backward blocks. It's two different terms which basically mean the same thing, they're just positioned in different directions. So here, for example, when you have let's say you have a joist hanger here, and you're dealing with that profile, you want something to nail to, we would call that a backward block. Okay, so it gives you something that gives you some meat to nail to. A filler block would be in between two I-joists like that. If you have a double joist running like that, and you've got concentrated load coming into the side, you want to make sure that the two joists are working as one. Okay, and you don't want to just be nailing through the top and bottom boards, because what happens if you have a two 2x4 flange joists, you have 7 inches wide, you'd have to use an 8-inch nail through the top and bottom boards and split the wood. Okay, so that's not the way to go. If you go through the top and bottom boards, you just risk splitting the wood. The way to go is to go through the web. Okay, so you put a filler here, and then you nail through the web, and off you go. So in the guides, there's some tables that would say what size of filler you need depending on what width of flange and all that. Okay, so that's what a filler block and a backward block is. Spoke of joist hangers. Joist hangers come in different sizes and shapes and flavors. This is kind of a hybrid hanger. This is a traditional face mount hanger where it's just nailed on the face. Okay, it could be full depth such as that one, which means it goes and touches the top board, or it could be a little as shallow as 60% of the height, where it doesn't touch the top board, and to prevent the I-joist from wobbling into the hanger, that's where you might need to have some web stiffeners or some little filler blocks here so that your I-joist isn't wobbling. Okay. This is kind of a hybrid here that has these little tabs on the top that kind of gauge the height to install the mat. And this is what we call a top mount hanger, which actually has tabs on the top, and it actually literally hangs from the top, and you nail it only on the top, you don't have to nail it on the face here. Okay, so there's different types of hangers, different details for the different types of hangers. We don't manufacture hangers, but kind of the leading manufacturer that does is Simpson Strong Style. So they have a catalog here with a gazillion hangers in there and all kinds of specifications when it comes to that. Okay. Load transfer. This is kind of framing 101. Okay, nothing too special about that. When you have a concentrated load coming from above, the individual joist isn't sized or designed to take up all that load. Okay, so you have a column coming from above, carrying a girder truss or some roof load or something coming down. Well, you can't all come down on one little puny eye joist there. You've got to add some what we call squash blocks on either side, kind of build it up so that the load gets transferred around the eye joist. Otherwise, the eye joist is going to want to crush at the bearing point here. Okay, so that's just a typical detail. Okay, the same thing if you're framing with 2x10s, it doesn't matter. Okay. So that's just kind of a detail of what squash blocks will do. Cantilever. Anybody tell me what a cantilever is?
Hanging over the end.
Yeah, there you go. So cantilever is basically where you have two supports or multiple supports, doesn't matter, but part of it extends out and is unsupported. Okay, so we see that sometimes where you've got a square box foundation, but there's a bump out for a fireplace, for example. Often they won't run the foundation around the fireplace; they'll just overhang the joists. Typically, you can safely go 2 feet out, and it's a no-brainer. If you want to go longer than that, then you have to start designing it to make sure that there's no excessive loads on the outside. Where there is a lot of load, let's say we're cantilevering out 2, 3, 4 feet, what have you, and there's the exterior wall over here, and you've got roof load coming down over here, well then the joist is going to want to do that, or it's going to want to shear off the end. So there's some different details on how to reinforce that joist. Okay, so E1, E2, E3, those are all different reinforcing details. So E2 would be a plywood reinforcement on one side, E3 would be on both sides, E4 would be you add an extra piece of joist, et cetera, et cetera. Okay? So those are different details we have to touch on that. Another common one would be what we call a brick cantilever. So where you have brick on the first floor walls, and then on the second floor they have siding. So vinyl siding, whatever kind of siding you have. And you want the outside face to be all one smooth finish. Well, obviously you've got a bit of a check that you have to do here if you want the exterior finishes to be the same. So this cantilevers out a little bit, and there's a few different details on how to do that. Okay. So we spoke of holes a while ago. So we see here, we've got a small hole over here, and as we get to the middle, we've got bigger holes. Everybody tell me why we've got bigger holes in the middle of an eye joist, as opposed to bigger holes close to the end? Any guesses?
To keep away from bearing holes?
Yeah, there's some tables that would say what distance you have to be, depending on the size of the hole and the size of the joist that you're using. But the fundamental reason why is because you've got, let's just say you've got 2 supports here again, okay? You're applying a bunch of load here. What happens to the joist? The joist wants to bend like this, okay? So the top of the eye joist is in compression and the bottom's in tension. Okay, so there's some forces happening inside of that joist. So the top is being compressed together and the bottom is being stretched out. And the forces basically annul themselves in the middle. Okay, so if you drew an X type thing, the middle point right in there, the web is doing virtually nothing because the top and bottom cords are doing all the work. So that's the fundamentals of an eye profile period, okay, versus a solid piece of wood. Which means the further you are in the middle of the span, the less of a roll of web plays, therefore the bigger a hole we can cut. Okay? As you get closer to the bearing, then there's not as much tension and compression going on the top and bottom, then there's more shear happening. And that's where the web plays a role there, so it doesn't cut off, or so it doesn't buckle, so it doesn't kind of wave on you. Okay? So that's why we have some hole cutting charts in the guide that would say, if you want to cut a 6-inch hole in a TJI 110 model, well, what distance do I need to be from the support? Okay? So you'll see there's a table in there, and that would tell you the minimum support from the face of the bearing to the face of the hole.